Good morning, girls. Today we will do trigonometry, chapter number 15. This is the last chapter. We have already started this chapter and we have done derivations of angle 45 degree, 30 and 60 degree. Today I am going to do the fundamental trigonometric identities. These are the formulas which are very important, and formulas we will apply in the exercise to prove the questions. Now this is the derivation of the formulas, and these formulas, sine, cos, tan formulas, these formulas known as identities. Okay, there are three main formulas, and with the help of three formulas you can make more formulas. So the first step is to draw the figure. Figure is very important in trigonometry because it is the study of the triangle. So we will make a triangle first. Okay, so right angle triangle we will make. You all know how to make it when you make it properly with a scale. Okay, proper figure. So we will make the triangle, right angle triangle. Okay, this is A, C, B. Angle C is 90 degree. Okay, so angle C is 90 degree. So triangle ACB, and angle A is theta, it is unknown. Okay, so you all know that opposite of the angle is known as perpendicular. Opposite side of angle is perpendicular, adjacent side is base, right? So this is theta, so opposite side is perpendicular, small a, adjacent side is base, B, and this is theta. Opposite of C is hypotenuse, small c. So these are the three sides of a right angle triangle. Now in the right angle triangle ACB, you have to mention also in right angle triangle ACB, angle C is right angle, angle C is right angle, and angle A here is, suppose it is theta, it is unknown, so suppose angle A is theta. Now you can see that there are three sides, so we will apply Pythagoras theorem. Okay, Pythagoras theorem you all know, so by Pythagoras theorem, Pythagoras theorem. Now according to this Pythagoras theorem, hypotenuse square is equals to perpendicular square plus base square, or you can say that perpendicular square plus base square equals to hypotenuse square. Same thing. Now we will write the sides according to these. So p square, p perpendicular is p, so it is a, perpendicular is a, and base b is small b. So we will write perpendicular is a square plus base is b square equals to hypotenuse is small c, c square. So this is name this equation, that this is equation number 1. Now for the derivation, we will solve this equation, and we will divide this equation one by one by a square, b square and c square to get three equations, three identities, you can say. So let's start with c square. We'll divide this whole equation by c square. It means divide each term by c square. So we will mention here divide equation 1 by c square. Okay, so let's divide a square divided by c square plus b square divided by c square equals to c square divided by c square. So we have divided each term by c square to get the first identity. Now a square upon c square, you can write it this way also, a upon c the whole square. So when you open the bracket, square will come on a and square will come on c. So the same thing you will get. Same we'll do with the second term, plus b upon c the whole square equals to, now this will get cancelled, so you will get 1. Okay, then we will change this into sides. What sides are these? A is, you can see in the figure, A is perpendicular and B is base and C is hypotenuse. So we will write the sides. A is perpendicular upon C is hypotenuse whole square plus B is base divided by C is hypotenuse the whole square equals to 1. Now you know that perpendicular upon hypotenuse is sine, and angle we are using theta, so sine theta whole square. So instead of perpendicular upon hypotenuse, we have written sine theta. Okay, plus same we'll do here, base upon hypotenuse is square cos theta, so cos theta whole square equals to 1. And when we open the bracket, we write square on sine and cos. We don't write square on theta. When we open the bracket, we write sine square theta plus cos square theta equals to 1. So this is the first identity. Okay, so first main formula, this comes in the MCQs also, that sine square theta plus cos square theta equals to dash. So you have to learn these formulas. So this is, you can say, first identity. This is identity number 1. Now you can make 2 more formulas from this by shifting these terms. Sine square theta will remain here. Sine square theta equals to cos square theta will go after equals to sine, so plus will change into minus. 1 minus cos square theta. And the third formula, cos square theta will remain here. Cos square theta equals to 1 plus sine theta will go that side, it will change into minus sine square theta. So that we have made 2 more formulas from this first identity. You can make 2 more. So these are the 3 formulas. Okay, so we have completed this first identity derivation. This is very important. These formulas you have to learn for the MCQs also and for the question answers. Now we will do the derivation of the second identity. you practice the derivation of this, it can also come in the paper, derivations. So let's do the second identity. Now the second identity, for this we'll again take the same equation. We will divide equation 1 by b square. So divide equation 1 by b square. So we get, let's divide it. A square divided by b square plus b square divided by b square equals to c square divided by b square. So this is the same equation, Pythagoras theorem, and we are now dividing the equation by b square. It means that divide each term by b square. So we will get, again we will change this into a upon b the whole square plus b square upon b square will get cancelled, so we'll get 1 equals to c upon b the whole square. Okay, same way we will solve. Then we will give the names perpendicular and base. A is perpendicular upon b is base according to the figure, square plus 1 equals to c is hypotenuse divided by b is base. Now you can change it. You know, perpendicular upon base is known as tan theta whole square plus 1 equals to hypotenuse upon base is sec theta and whole square. Open the bracket. The square will come on tan square theta plus 1 equals to sec square theta. So this is the second identity, main identity. This is number 2. Second identity, and you can make 2 more by shifting the terms. Tan square theta will remain as it is. Tan square theta equals to 1 will go that side, plus will change into minus sign, sec square theta minus 1. And third formula, 1 will remain here, tan square theta will go that side, so sec square theta minus tan square theta. So we will write this first, sec square theta minus tan square theta equals to 1. So these are the 2 more formulas which you can make from second identity. So this way we have completed derivation of the second identity. Now we'll do the derivation of the third one, last identity. And these formulas then you can learn, and then we will apply these formulas to solve the questions. Okay. Now in the third one we have divided equation by b square, and in first one we have divided the equation by c square. Now we will divide the equation by a square. So the third derivation, divide equation 1, same equation, by a square. We get Now if it comes in the exams to derive, you will write the equation. You will not write equation 1 because you don't have to do all three, only one can come. So you write the Pythagoras theorem and then divide the equation by a square or b square or c square, whatever they have asked in the question. So let's divide Pythagoras theorem by a square. A square divided by a square plus b square divided by a square equals to c square divided by a square. So we have divided each term by a square. Now rest is same. A square and a square cancel, so 1 plus this will change into b upon a the whole square equals to this is c upon a the whole square. Now change it into perpendicular base and hypotenuse. So 1 plus b is base upon a is perpendicular the whole square equals to c is hypotenuse h divided by a is perpendicular the whole square. Now we will change it into sine cos form. So this is 1 plus base upon perpendicular is cot theta the whole square equals to hypotenuse upon perpendicular reciprocal of sine cosec theta the whole square. Now again same way, open the brackets, 1 plus cot square theta equals to cosec square theta. So this is the third identity, third one. You can make two more identities from this by shifting the terms. So if I shift cot square theta that side, 1 will remain here equals to cosec square theta minus cot square theta, right? Second, now cot square theta will remain here, 1 will go that side. So cot square theta equals to cosec square theta minus 1. So these are the two more formulas from third identity. So it means altogether there are 3 plus 3 plus 3, 9 formulas. 3 from 3 identities, main are 3 identities. So learn main 3 identities and remaining formulas you can make by shifting the terms. So altogether these are 9 formulas. Okay, so you have to learn all for the MCQs. And if you want to attempt the question in the short question answers, then also you have to learn. If you are going to attempt or not, you have to learn the formulas for the MCQs. So you can say that equation 1, 2 and 3 are called fundamental identities. Okay, so this derivation is complete, and now I'll do the examples first. Okay, few examples I'll do from your book, whatever examples are given. Let me solve this. Okay, this is example number 1. Prove that sine theta equals to plus minus and root 1 minus cos square theta. Now you can see left hand side and right hand side, two sides are given. We'll take any one side and then we will prove it with the help of the formulas. So let's take left hand side. is sine theta. Okay, now we will prove this side, okay, if it is equals to the right hand side or not. Now we have just now finished the formulas. So what we'll do, we will write the formula. We know that sine square theta plus cos square theta equals to 1. This is the formula. So we'll keep sine theta one side. Sine square theta equals to 1 minus cos square theta. Shift cos square theta after equals to sine, so plus will change into minus sine. And required is only sine, so we will take root on both sides. Okay, take root on both sides. So it means under root sine square theta equals to under root 1 minus cos square theta. Root and this cancelled, so sine theta equals to, when you take root you write both signs, plus minus under root 1 minus cos square theta. So you can see that this side is same as that side in the question. Okay, so left hand side equals to right hand side. Proved. Only this you have to do. You have to learn the formulas and you have to prove the question using the formulas. Okay, but learn the formulas, and you can easily do the. Now we are going to do the second example from your book. 1 minus sine theta divided by cos theta equals to cos theta divided by 1 plus sine theta. You can take, okay, we will take left hand side. So left hand side is 1 minus sine theta divided by cos theta. Now in this case we will multiply and divide the equation by 1 plus sine theta. Conjugate, you can say, you have done conjugate in the search, so you will change this minus sign. So multiply and divide by 1 plus sine theta. Okay, so let's multiply and divide. 1 minus sine theta divided by cos theta multiplied by 1 plus sine theta. Conjugate is 1 plus sine theta divided by 1 plus sine theta. Numerator into numerator, denominator into denominator. So numerator is, you can see, a minus b, a plus b. So apply the formula, 1 the whole square. This is a square minus b square. B is sine theta the whole square divided by cos theta and 1 plus sine theta in the bracket. Now we can still solve this. So this will become 1 minus sine square theta divided by cos theta 1 plus sine theta. Okay. Now after this step we know this formula, so we will write, we know that this is a formula. Formula is cos square theta equals to 1 minus sine square theta. This you all have understood. Numerator into numerator, it is a minus b. A plus b is a square minus b square. Denominator into denominator, cos theta into 1 plus sine theta. Now this is equals to 1 minus sine square theta, and denominator as it is. This formula we have already done it, so we know that cos square theta is 1 minus sine square theta. So this numerator we will replace by cos square theta. So cos square theta divided by cos theta into 1 plus sine theta. Now one cos will get cancelled, so the remaining is cos theta divided by this bracket 1 plus sine theta. So if you see the question, required term you can see here, required is cos theta upon 1 plus sine theta. So this is the required term, cos theta upon 1 plus sine theta. So you can say that left hand side equals to right hand side. We have proved it. Okay, left hand side equals to right hand side. Proved. So easy it is. Only if you know the formula you can put the value and then you can easily solve. Okay, another example from your book. Now this is the third example. You have to prove cosec square theta minus 1 and sine square theta equals to cos square theta. So we will take left hand side. So left hand side left hand side is cosec square theta minus 1 into sine square theta. Now this is also the formula. We will apply the formula here. Okay, let's apply the formula. We know that means if you have learned the formula. So formula is cosec square theta minus 1 equals to cot square theta. Cosec square theta minus 1 is equals to cot square theta. So we will replace this bracket and write cot square theta into this value sine square theta, and we already know that cot theta is cos square theta upon sine square theta into sine square theta. Okay. You can mention it that cot theta is equals to cos theta upon sine theta, and tangent is sine upon cos, so this is reciprocal. It is cos upon sine. Sine and sine will get cancelled, so we will get cos square theta. So it is same as that this left hand side. So we can write left hand side equals to right hand side. So the main thing is to learn the formula. So if you know the formulas, you can easily do. Example number 4 I'm going to do from your book, example number 4. Okay, now example number 4 is given. It's in your book. If cot theta equals to 4 upon 3, cot theta is 4 upon 3, find the remaining trigonometric ratios. It means cot is there, so you have to find sine, cos, tangent, cosec, sec. Okay, so whatever these values are given, we will write the values first. So given given value, it is cot theta equals to 4 upon 3. Okay, this is given, and we know that cot equals to what? Cot theta equals to base upon perpendicular. So we will draw the figure now. Okay, and we will write the values. So let's draw the figure. Proper figure you are going to make with the scale. Okay, use the scale. Right angle triangle, A, B and C. This is 90 degree, and suppose this is angle theta. According to this is perpendicular, and this is B, and this is base is A, and this is hypotenuse is C. Now according to this is base upon perpendicular 4 upon 3. So base means this base is 4, so it means A is 4, and perpendicular is 3, it means B is 3. Okay, so you will make the figure according to the question. Whatever values are given, you will write it and then solve it. So it means that value 4 is A and value 3 is B divided by B. Now you can see two sides are there. Find the third side. So the third side you can find by Pythagoras theorem. So we will apply by Pythagoras theorem. So the formula is hypotenuse square equals to perpendicular square plus base square. You all know this formula. Hypotenuse is C square equals to perpendicular, you can see is given, it is B square plus base is A square. Now you can put the value C square as it is equals to B square. Value of B, or in the figure also you can see it is 3. So 3 square plus A. Value of A you can see is 4, or here you can see A is 4. So 4 whole square. So C square equals to 9 plus 16 and C square equals to 25. We will take root to find C. So the value of C is root of 25 is 5, and we will take only positive roots, not the negative ones. So now we know the value of C, we know all the values. A is 4, B is 3 and C is 5. So you can find the remaining trigonometric ratios. Therefore let's start with sine theta equals to perpendicular upon hypotenuse. So perpendicular is B upon C. So value of B is 3 upon C is this in value 3 upon 5. Then same way you will find cos theta cos theta equals to base upon hypotenuse, and it is a upon c equals to 4 upon 5. Then tan theta is perpendicular upon base b upon a, and values are b is, you can see, 3 and a is 4, so 3 upon 4. Okay, remaining 3 also you'll find. Remaining 3 are the reciprocals. Cosec theta equals to c upon b is 5 upon 3. First one, reciprocal of first. Sec theta equals to c upon a, reciprocal of cos, it is 5 upon 4. And last one is cot theta, reciprocal of tan, so this a upon b equals to 4 upon 3. So these are the all trigonometric ratios. Only one value was given, cot theta, and with the help of that you can find the remaining trigonometric ratios. So we have done this also. If value is given, how to solve the all 6 ratios. So identities we did, and we did examples. With the help of examples, with the help of identities, how to solve the examples questions. It comes in the short question answers. In the model paper also you can see that this one question, identity question, proof question, is in the model paper. So please practice, do the derivation, and it's easy. You learn main 3 formulas, and with the help of main 3 you can make more formulas. Okay, so I hope you have understood these identities. This exercise based on these identities, 15.3 it is. I'll try to do the exercise also, and you also girls try to do question number, don't do the first one, start from the second question. Okay, second is onwards are important. Onwards, second question from 1 onwards are important, and examples also you practice. Okay. Anything you don't understand, just let me know, message me anytime. Just tell me that you have not understood the questions. Okay, so exercise also I'll tell you. You also please try to do the exercise. Okay, next time I'll do the next topic. Only the solution I will send you, or if you have any problem, any question that you think is difficult, that the questions few, I will do it in the next lesson. Okay, so take care girls, bye.